Okay, so we've seen what you can do if you start with a negative in a radical, you pull out the I. But what happens when we already start in the form a plus bi? So we're already given problems in terms of complex numbers. So I have something like 3 minus 4i plus negative 2 plus 6i. This is just a situation where you combine like terms. You have a number and a number. So it gives you 3 plus negative 2, that's just 1. And I have negative 4i plus 6i is a positive 2i. That's it. See, I know I'm beating this drum here, but are we really talking about complex numbers? I don't think so. This stuff's easy breezy. What if I have something super awesome like this? We have negative 4 plus 3i minus 6 minus 7i. Okay, now whenever you have polynomials and you are subtracting, what do you get the amazing opportunity to do? Distribute the negative. So now I make this a plus and I distribute the negative to both terms. So that's a negative 6 and a positive 7i. Then you're back at it again. Negative 4 and negative 6 is a negative 10. A positive 3 and a positive 7 is a positive 10i. That's it. No need to factor. If you're looking at that saying, ooh, they have a 10 in common. No need to factor. Just leave it like that. You're in good shape. Cool. So we know we can add and subtract. Let's do a little bit of multiplication here. If I have, for example, 5a, parenthesis, 2 minus 3i times 3 plus 4i. The same concept here happens when you were adding and subtracting. You just treated it like a polynomial. You're going to do the exact same thing when you multiply this stuff. So do work. So I have 2 times 3 when we FOIL this out. And I know I'm going to FOIL because my 2 sets of parentheses are touchy-touchy. So pay attention to that. Whenever you had the problems we just did, there were a plus or minus sign between the parentheses. When your parentheses are touchy-touchy, multiply. Cool, we got this thing. 3 times 2 is 6. 2 times a positive 4i is a positive 8i. Negative 3i times 3 is a negative 9i. Negative 3i and a positive 4i is a negative 12i squared. Now, remember, we are putting these in standard form, which is a plus bi. Your I can only be I. It cannot be I squared. It cannot be to any exponent. So as soon as you see this I squared, I like to just cross it out because it's the same thing as multiplying by a negative 1. So that takes negative 12 times negative 1 becomes a positive 12. So anytime you multiply by a negative 1, all you're doing is just changing the sign. So I just cross out the I squared, put an arrow to show that I've changed my sign. Then you just combine like terms. Positive 6, positive 12 at this point will give me an 18. Positive 8i and then negative 9i is just minus 1i. So you can just put negative i's. There's no need to put a coefficient of negative 1 there. Pretty cool, right? Let's do more. Okay. Let's do it right now. We have example 5b. We get the opportunity to do 4 plus 3i with the quantity squared. Now, if you have a binomial squared, what do? 2 shots. You can do writing them out independently. So you have the 4 plus 3i, and then you can multiply that by a 4 plus 3i. You may not distribute that squared term because of that plus sign. So at this point, you can FOIL that out, and it gives you 16 plus a 12i plus 12i plus a 9i squared. Cross off that I squared and make that a negative 9. So 16 minus 9 is 7 plus a 24i. There's round 1. Here is round 2 with the same problem. As soon as you have a 4 plus 3i, the quantity squared, you can square the first term, multiply the two inserts inside terms together by 2. So it would be 2 times 12i, giving you a 24i, and then square the last term. So instead of writing out this 12i and 12i, you can do the shortcut method in essence. It still makes this a negative, and you still end up with the same answer. I'm kind of running out of room. 16 minus 9 is still 7 plus a 24i. So regardless, you end up with the same answer. It's just your choice in the method that you want to do to get there. Okay, so my problems are starting off with an I in them already, but what is I? Remember, I is still the square root of -1. So what if I have a problem that's super awesome like this? 6 plus 5i times 6 minus 5i. So if you notice, we have the exact same thing in parentheses, except one's a plus and one's a minus. What do you know about that? Think factoring. What do you think of? Difference of squares, right on. Okay, now think radicals. And what do you think of? If it's the exact same thing in parentheses, except one's a plus and one's a minus, starts with a C. What's that called? Conjugate. Yeah. Okay, hang on to that. We'll come back to it. But if you have the exact same thing in parentheses, one's a plus and one's a minus with radicals, it's called a conjugate. Okay, check this out. So let's FOIL this bad boy out, and what do we get? 6 times 6 is 36 minus a 30i plus 30i minus a 25i squared. So the negative 30 and the positive 30 cancel out. This I squared makes a plus. So now we just have 36 plus 25. What's that give us? 61. Check my math. Yep, I think we're good. Okay, so we now have 61. Do we have any more radicals, aka i's, in the problem at this point? No, we do not. That is super awesome. So if I am going to get rid of the I values, that is where the difference of squares comes in. Same thing, if I have 6 plus 5i, 6 minus 5i, because it's the difference of squares, you can square the first term to be 36 minus a 25i squared. You know the middle term's going to cancel out, so you don't even have to mess with it. Then the I squared becomes a plus, and you have your 61. Cool. Let's do more. So now we've added, we've subtracted, we've multiplied. What's left? Yeah, it is. Let's do a little division. So, if I have this example 6, 3 plus 2i divided by 5 minus i. Now, as soon as you look at that I, you know that's the same thing as a radical. Can you have a radical in the denominator? Negatory, good buddy. If you can't have a radical in the denominator, then what do we get the opportunity to do? Now remember, there's a plus, or pardon me, in this instance it's a minus, but there's a plus or minus sign in the denominator. What do we get to use? Starts with a C, and we just talked about it. That's right. We'll get a little conjugate action going on here. So, what's the conjugate of 5 minus I? 5 plus I. Sweet. It's the exact same thing in parentheses, except one's a plus and the other one's a minus. Whatever you do to the bottom, you have to do to the top, because essentially we're just multiplying this by a 1. If you're struggling with radicals, then go back to that section that I have in your homework that says not for a grade, radical expressions, and do some. That talks about conjugates, that talks about rationalizing denominators. You'll get a nice good review in that instance. But moving up and on here. Okay, let's do it right now. So, FOIL out the numerator, and I end up with 5 times 3 is 15 plus 3i plus a 10i plus a 2i squared all over, and square the first term giving me 25 minus square the first term, which is an I squared. Cool. Then the I squared becomes a positive 1 because that's our coefficient. And don't forget, this I squared makes that a negative 2. Cool. So 15 minus 2 is 13. 3 plus 10 will be a 13i in the numerator, all over 26. Now remember, when you write these problems, you need to write them in standard form. So we want to end up with an A plus BI format. Again, I have a monomial, which is a single term in the denominator, so we can split this up to be 13 over 26 plus 13 over 26i. Can you reduce that? Well, heck yes, you can. 13 goes into 26 two times, so I now have a 1/2 plus a 1/2i. Pretty cool, right? Nice.